Welcome back to the M25 AAHL Time Zone C Paper 2 walkthrough. Today we're going to go over question 10 on kinematics. This is a very straightforward start to the paper, to section B. So, in question 10, you're given Fiona's and Lucy's velocity functions. In part A, write down the value of V1. Trivial. If you want to be careful, make sure to include units. A2. Find the time when Fiona's velocity is 5 meters per second. You're given the velocity function. So, and solve. Bing, bang, boom. And that's the final answer. Part B. Find the time when Fiona's acceleration is 4 meters per second squared. Acceleration, that is the derivative of the velocity function. So all you have to do is to solve the equation dv by dt is equal to 4. And using your CDC, you should get this value. Part C. Write down the limit of v of t as t approaches infinity. Another straightforward question. You can include a sketch for the function if you wish. This is optional. But if you wish, you can always quickly sketch out the function. And you would see something like this. And the limit is 8.14. 2. State a reason why the value in part C1 is not valid. Well, because the run doesn't last forever. They only race for 30 seconds, a minute max, so you will never get to the limit that you just found in C1. Part D is where the fun is. You know that Lucy and Fiona starts at the same time. The finish line is 200 meters away. Fiona finishes first. Lucy finishes after. And they're asking you the distance between the two when Fiona crosses the finish line. So to do this, 1, we have to find the time it takes for Fiona to finish. Because they start at the same time, this is also the amount of time that Lucy gets to race. So the distance Lucy covers during that time. And 3, we know the entire thing is 200 meters long, so the distance between the two will be 200 minus the answer that you have found in 2. So first off, how long does it take Fiona to finish the race? Let's say they finish the race after Fiona. Let's say that Fiona finishes the race after t seconds, capital T. So we know that this has to be true. Why is that the case? Because this function is positive already, so you don't need to have the absolute value signs around it. Solving this integral is not too bad. You just have to do a use up. So if u is equal to t squared plus 0.2, the u, that's going to be 2t, changing the bounds. T goes from 0 to big T, u will now go from 0.2 to t squared plus 0.2. I'm just going to quickly prepare this integral. So Oh, I forgot dt over here. We gotta isolate dt. So we gotta have 1 over 2t somewhere. 2t dt. Over here we have 8.14t divided by this guy. This part now becomes du. 0.2 t squared plus 0.2. That part now becomes 4.07 divided by square root of u du. And integrating this guy is trivial. Upper bound, lower bound. Plug it in. And that is the distance that she has covered in t seconds. Now, we know that that integral has to be equal to 200. So, now we've got to solve the equation. And you will get t is equal to 25 seconds. Step 1, done. Step 2, how far has Lucy traveled in 25 seconds? So that's the integral from 0 to 25 of wt dt. And you shall get 195.67. Therefore, the remaining distance that Lucy has to race is 200 minus this value over here, and that will give you 4.33 meters. And that is the end of question 10. Pretty straightforward. Question 11 on binomial distribution. Part A, we have Amanda entering 50 surveys with an inaccuracy rate of 8%. So let x be a number of surveys that Amanda enters incorrectly. We know that it follows binomial distribution with n equals to 50 and p equals to 0.08. A1, find the probability that she entered at most 6 surveys inaccurately. So, using the TZC, one shot, you would get 0.8981. Part 2. Given that at most 6 surveys were entered inaccurately, find a probability that exactly 4 were entered inaccurately. We have a conditional probability. In other words, we want to find p of x is equal to 4 given that x is less than or equal to 6. So that means we're going to find p of x is equal to 4 divided by p of x less than or equal to 6. And you will get 0.629 divided by 0.8981, and you will get 0.700. Part B. On a different day, Amanda enters data from n surveys. And we know the probability that x is less than or equal to 6 is 0.367. And for this guy, I would recommend making a table. We have a higher probability, we have a lower probability of this happening. That means that she had to enter more data. She had to enter more surveys. So you can create a table or something similar, and after a bit of messing around, you will get n equals to 94. In part C, now we have her friends, Bryce and Carmen. We are given that Bryce and Carmen's entries are inaccurate 6 and 11% of the time, respectively. We also know that Amanda, Bryce, and Carmen enters 55%, 25%, and 20% of the surveys, respectively. So this is an obvious code for a tree diagram. Out of all the surveys, Amanda enters 55%, Bryce enters 25%, Carmen enters 20%. Out of those surveys, Amanda enters incorrectly 8%. That there's a mistake. Bryce enters 6% inaccurately, and Carmen 11%. That means that the probability of having no mistakes for Amanda is 0.92, for Bryce is 0.94, and for Carmen is 0.89. Find the probability that a randomly selected survey was entered inaccurately. So we have three pathways, right? Either it's inaccurate due to Amanda, or due to Bryce, or due to Carmen. So that is equal to 0.55 times 0.08 plus 0.25 times 0.06 plus 0.2 times 0.11. And that will give you 0.081. B2. Find the probability that a randomly selected survey was entered by Amanda, given that the survey was entered inaccurately. So it is another conditional probability here. I do not know why they want to test this concept twice. But now it's P Amanda given inaccurate. So how do we find this probability? P of A given B, that is P of A intersecting B. So in this case, it's a probability that Amanda enters an inaccurate survey divided by the probability of being inaccurate. P of Amanda, that's 0.55. P inaccurate, that is 0.08, divided by the same denominator. And you will get 0.543. Now we are going on to part D. The following year, the accuracies of Amanda's and Bryce's work remained the same as did the percentage of the surveys entered by each of the three employees. However, Carmen's accuracy has improved, and the probability that she entered a survey inaccurately was now X%. So, in other words, this stays the same, that stays the same, that stays the same, that's the same, that's the same. This is going to change. And instead of having it at 0.11 or 11%, now we have X%. And this guy will now become 100 minus X%. And we are asked to find the value of X. What else are we given? Now we're given that the probability that a randomly selected survey has been entered inaccurately, so P inaccurate, is the same as the probability that Carmen made an error when entering a survey. P Carmen error. The probability that Carmen makes an error, that's X%. The probability that a randomly selected survey has been entered inaccurately, that is 0.55 times 0.08 plus 0.25 times 0.06 plus port 2 times x percent is now equal to x percent. Solving the equation, you will get port 8 times x percent is equal to 0.059. Thus, x is equal to 7.38. And that is the end of question 11.